This particular subject, GraphQL, I attended a talk at a O'Reilly open source conference a few months ago, and read articles, read a book about this. This is not something I produce personally, so this is a caveat. The purpose of this talk is not to give you all ins and outs of GraphQL. My main objective is to first explain why this technology is worthy of your attention, and explain how the technology works, what are the sort of underlying concepts, and give you some ideas if you want to try GraphQL, what the space is, what the tools are, how you go about that. Unfortunately, I'm not able to use my laptop. It doesn't have HDMI connection here, so
does it have USB-C?
No, it just has the standard display, so that's fine. Yeah, that's fine. So I hope that the demo part will work. Again, it's also browser-based, but should not be a problem. So with that, let's go into GraphQL. So let's start with REST. REST stands for Representational State Transfer, and it's an architectural set of architectural principles based on which we have been building web services, interfaces between web clients and backends for many years. I think it was a subject of a PhD dissertation by Ron Fleming in 2001. So it's been a while. And right now, it's considered a de facto standard in the space. If you're connecting to a backend from your browser-based applications, most likely you're going to use REST. So let's talk about what REST is, why it's so popular, and why it's getting longer. So REST is based on HTTP protocol, which is ubiquitous, which is how typically the browser talks to the backends represented by web servers. It uses the standard HTTP mechanisms like HTTP verbs, query parameters to express its semantics, to express the meaning. And here are some of the design principles listed here. So the server is stateless, meaning that each subsequent interaction is not dependent on the previous interactions. There is no state maintained on the server. Uniform interface, here I mean that when you design your API, you use URL structure in a uniform fashion. So once somebody sees a few endpoints, he should understand pretty well what your API looks like. Everything is a resource. And again, you use the URL structure to pinpoint a specific resource. In databases, there is the term CRUD, it stands for create, read, update, delete. And since most applications deal with life cycle or some kind of entities where you do, you create, read, update, and delete them, you use corresponding HTTP verbs to perform the corresponding operations. You use the, for creation you use post, for read you use get, for update you use put, and for delete you use delete HTTP method. You use the URL structure to pinpoint to specific entities and explore associations between entities. So for example, you want to get all the classes of a specific student in a college application, a college registration application, for example, you may say student-1, student/1/classes. You can use the URL parameters for filter sorting and pagination. You can do global and local searches So for global searches, you probably have a search endpoint with some parameters. And for local searches, you have students and maybe a student ID or some more intricate way of finding students. You use HTTP error codes for handling, for conveying the error conditions to the client, and JSON is typically used as a data exchange format. Again, it became ubiquitous. So if you're familiar with REST, probably those principles sound familiar to you, and they are what makes REST such a strong contender. Right? Its familiarity, its simplicity, its power expressed in the familiar HTTP artifacts. REST has some drawbacks, and GraphQL was designed essentially to fix the drawbacks of REST. So let's see what they are. Poor data discovery. You may publish your API, but you don't have to. It's not guaranteed that if you have a server which provides a RESTful API, there is no guarantee that this API will be well documented and available. Multiple fetches, that's underfetching. So what I mean by multiple fetches, let's say you design a web application. So the goal of those RESTful requests is to populate your page, right? And it's pretty common for a single page to initiate multiple REST calls to bring back its content. Fetching extraneous data. By the same token, each of those REST requests, there is no guarantee that it's bringing you exactly the data that you need. It can easily bring you more data than you need. No query validation. Again, you construct a URL, you send it to the server, and you hope for the best. There is no standard way of validating which URLs are valid and which are not. And as your API matures, as you add and change things, there is no easy way to say that I'm on version X on my API and being able to determine what's available, what's not available, and how to handle the evolution of the API. So let's look at a specific example which demonstrates these issues I just mentioned. So in this case, it's somewhat a contrived example, but it's a blogging application, and the objective is on the page you want to display for the given user the titles of that user's posts and some information about the user himself or herself, and the information about the last 3 followers of the user. So here on the right, you see 3 requests that you have to perform, and on the left you see each of them. So the first one is the get request. You user/ID, and you get the information about Mary with her address and her birthday, although that information wasn't really necessary. But because this is the way the API was designed, because surely somebody will need birthday and address information of the user. That was included into that specific endpoint. So that's the second call. Here we get back an array of posts, and you see the first item of that array for the same user. And again, we don't really need comments here. All we need is the titles of those posts, but all the information that was added to the specific endpoint was returned here. And you may say that you don't have to return it. You can design endpoints specific for this use case, which is probably true, but again, that leads to the huge proliferation of endpoints if you try to cover every situation, because in some cases you do need comments, in some cases you don't, so you have the choice. And you have multiple endpoints tailored finally to each page needs, or have sort of fewer endpoints which return more information. So neither choice is ideal. and on computer. And the last one is it returns information again in a JSON array about the folders with exactly the same issue. So here you see an example of both underfetching, meaning that you have to perform 3 requests. There was no way to perform a single request that would give you all that information. And overfetching, because each of those requests would return data that you didn't ask for. And as I mentioned, oftentimes you would have a large proliferation of endpoints for exactly that reason. If you try to make endpoints more efficient, you will see an explosion of that. So this is, I know we haven't talked about GraphQL yet, but this is an example of a GraphQL query. So at the top of the screen, what you see is the query which the client would send to the GraphQL server, and below, at the bottom portion of the screen, you see the data that gets returned. So the GraphQL query allows you to define precisely the information that you need from the server. And this is the exact information that gets returned in a single query. Questions so far? Okay, so I put out 2 quotes, 2 companies using GraphQL. This is from GitHub. Take a moment and take it. So this was a while ago, and this blog entry I found a few days ago, actually. And this is a pretty powerful testament to the success they were able to achieve with GraphQL, with decreasing the amount of data they were fetching from 10 megabytes to 100 kilobytes. And it was an article and a video. So, GraphQL and REST, typically adoption of new technology, companies are resistant to that for obvious reason, because you have a learning curve, you have existing applications which already work, and you have to reach a certain pain point before you start you decide to start all over again. So these technologies, they can work together. What you can do, you can set up a GraphQL server and use your existing REST API as a way to obtain information in GraphQL, and then slowly replace them with a sort of more native implementation of the resolvers, and I'll explain what that means. And by the same token, I'll talk about it later, you can use GraphQL as a facility of multiple systems. And each of them might have the RESTful or use another way of communication. So yeah, so this gives you a way to incrementally adopt GraphQL. All right, so let's talk about GraphQL itself. Try to understand how this technology is able to achieve this goal. So some definitions: it's a query language for the API and server-side runtime for executing queries by using a type system you define for your data. And it's not tied to any specific database or storage engine, and is instead backed by your existing code and data. So this is a mouthful, and over the next hour or so, I'll try to explain what this means. So let's first talk about what this graph in GraphQL is. So when I learned about GraphQL technology, it was pretty heartwarming to see. Why? Because GraphQL is based on the idea of domain modeling. And I was coming up in this industry in the 90s, and object-oriented programming was all the rage then. And the application of object-oriented programming to build systems, specifically domain modeling, was a big deal. And unfortunately, I think that nowadays, somehow these ideas, somehow they fell by the wayside. And oftentimes you build systems without trying to model your domain. And GraphQL, to use it effectively, you would have to do that. So what they mean by graph? By graph, they simply mean your domain model. And why it's a graph? Because in domain model, if you represent it using like a UML diagram, relationships between classes, that's a graph. You have your entities, and entities have relationships between them, right? And you can say that it's not really a graph, it's a hierarchy, but again, it comes down to the same thing. You have nodes and you have relationships between them. So, at a high level, the idea of GraphQL is you take your domain model and you create a single endpoint corresponding to the entire domain model. And then your GraphQL queries allow you to carve any piece of the hierarchy based on what was defined in the in the schema, in the GraphQL schema. You can request any part of it. So this is the idea of mathematical abstraction, that mathematicians, software engineers, we deal also with abstraction. So what may look like totally different things to professionals in other fields, we oftentimes we say, no, that's the same thing. So those are different examples of graphs. So those are the core concepts of GraphQL. You have a schema definition language, which allows you to define queries, mutations, subscriptions, and resolvers. So the first three, they define, like in, who is familiar with SQL, SQL? Most of you. So again, both are query languages, and in SQL, you have your data definition language and you have your data manipulation language, DDL and DML. Probably nobody uses those terms nowadays. Again, that's like 20-year-old technology, although still alive and well. But this would be, you have some of that in GraphQL as well. Another concept that's has been making an appearance in different places is the specification versus implementation. So in GraphQL, you separate structure from behavior. And how many Java programmers are here? Okay, so fair amount. Java made this idea that you should code to interfaces. If you look at any API designed to be widely used, let's say take JDBC API. All the classes that use in JDBC API are actually interfaces, right? You actually have no idea what implements them. That's the driver's job, right? And so you should be comfortable with that idea, that you deal with interfaces. And GraphQL does it on two different levels. So on one hand, GraphQL itself is a specification. So there are some parts of GraphQL that are totally agnostic of the underlying implementation. And you're going to implement your GraphQL service in a specific language, and it supports a whole bunch of languages. But the schema is part of the specification. So that's a GraphQL defined language that has that does not change regardless of what language you're going to use. And then implementation is for every language, be it JavaScript, which is probably the most common way to implement it, or Java or Python. There are bindings to that language. And then in the schema itself, you also have the separation between structure versus behavior. You have you first define all the interfaces, and then the resolvers are the implementers of those interfaces. So again, one reason I like GraphQL, because again, it forces you to model your domain. If you do that and you do it carefully, and you design sort of a language, and name your types correctly, and decide what are the ways that your object should be queried, then whoever is going to use your API, your GraphQL API, they're going to have an easy time of taking advantage of it. And it gives you, again, this generic way GraphQL schema to realize that. So this is from one of the books on GraphQL. This is sort of like a UML diagram, but he represents, in that book he teaches how to represent your domain model, uses the more like graph-like notation as opposed to the more familiar the UML where you have those rectangles of entities and arrows representing some kind of relationships or associations between them. So GraphQL, it has queries, it may have interfaces, it may have unions, enums, may have subscriptions, invitations, may have inputs, and so on. So those are things that we define in GraphQL, and I'm going to go over them and explain to you how they stack together. Any questions so far? So schema is the mechanism available by GraphQL to define your server's API. It defines a clear contract for client-server communication. And we'll see how that contract is expressed. What you get for free with GraphQL is the documentation. And I'll show you how it works. So as you define your schema, your server, Apollo server, or whichever provider you use, will publish the documentation, and you can see exactly what types and what queries and what mutations are available. GraphQL schemas are language agnostic, meaning that you design a schema using GraphQL schema language regardless of what your underlying implementation language is. So that's an example. In a typical blog application, you would have blogs, and blogs consist of posts. So this is, you see here two types expressed using GraphQL schema language. But again, if you're familiar with definition of classes in Java or any other object-based language, this should look familiar, right? That's one of the advantages of any new technology. They're trying to utilize existing concept, existing constructs. This is why Rust was so popular, because again, it was based on all the existing concepts. This is why Java became so popular, because it was using familiar C syntax, trying to attract as many developers as possible. And then it adds something new, it adds some value. So you can see that these two types, and the interesting thing is that post has a reference to blog, and blog has a reference to posts. So this is your graph. This is how you define relationships between these objects. And we'll go through what some of the quirks of this notation mean. Some definitions. So the biggest part of your schema will be the object types, defining your domain entities. And type has a name, can implement one or more interfaces. I'll explain what interfaces are in a second. And type consists of fields, which are defined by name and type. And a field can be of scalar type, or it can be of a more complex type, like an enumeration, or an object, or a collection or a list of objects. Enumeration is same as enumeration in any other language. It's a collection of valid values, and it serves the purpose of A, communication, and B, validation. So it communicates what the valid values are, and second, when you write your queries, you cannot enter the values that are part of the enum.
I saw that I see that the blog has a relation to posts. But posts also have a relation to other posts. Or are they supposed to have a relation to the blog?
It's probably a type.
Okay.
Relation to what thinking. interface. So interfaces here are slightly different than interfaces in Java. This is a simple concept. Here, interface is a type which you can extend, and by extending, you simply say you're saying that whatever fields I have in my interface, they must be present in the interface that implements it. And this is the explanation of what how we define a type. So this is a type from a Star Wars API, and I'm going to show some examples from Star Wars API. So there was somebody created a Star Wars RESTful API as an example of a REST API, and it was only logical to define a Star Wars GraphQL API. And I'll get some examples from that. So this is a Star Wars character who has a name and appears in some Star Wars episodes.
Is the exclamation point just the end of the line, or is it another meaning?
It has a meaning, and anybody who ventured to guess what the meaning of exclamation point is? Sorry?
It doesn't accept null.
It doesn't accept null.
Unknowable.
Unknowable, yes.
Okay.
Yeah. So yeah, exclamation point means that the value that you will not receive null in this value, and in the arrays you can have exclamation points both inside the array and outside. So here we have outside the array, that it means that the whole array cannot be null, and on the inside it would mean that the values cannot be null inside the array. Those are built-in scalar types. This is the example of an enumeration. I think it was at the GraphQL session that I attended at the OSCON conference. The presenter, he used a turn of phrase which I liked. And he asked, I don't remember, he asked about enums or something else. His question was, for example, why are we using enum? What's the advantage of them? And his answer was that because it makes it easier to reason about your code. And I like that answer, and you can use it in many situations where when you're trying to decide on a design choice, it's a good criteria to use. Whatever design choice would make it easier to reason about your code, you should probably use it. So this is an example of interfaces. So we have an interface character which has 4 fields. And the fact that human and droid implement character, it means that those 4 fields must be used in the definition of them, or they have to be repeated. And the way it's used, so in Java we have polymorphism, right? So we can define the return type of the interface type, and you don't know what object that implements the interface is going to be returned. So it's not true polymorphism here, but you can say that I'm returning characters, and then you know that whatever type implements interface characters can be returned. But in Java, you know that you can call certain methods. Here, you know that you can expect to find certain fields. So similar concept.
So you have to define them again?
Yes, you have to define them again. All right, so what do you do in those types? So let's say you define your domain model. All your types, all the relationships between them. Your API consists of the types, queries, mutations, and subscriptions. You will typically have queries. This is queries allow you to get information from the server. If you need to update the server, you will have mutations. So this is your read, and this is your create, update, and delete. And subscriptions, this is PubSub. This is a way to get notified of certain events. So I'm going to go into a specific example. So this is used in the O'Reilly book about GraphQL. So the authors of the book, they designed a fake website it's a snow-tooth ski resort. And these type definitions, they're from their GitHub repository. And so I'm going to go through definition of types, queries, and mutations, and then we'll query that resort to see how they all work together. So you understand what it introduces. It's pretty simple interface. It introduces two notions of lifts and trails. And lifts, they serve as trails. They provide trail access to certain trails. And those are the parameters that are used in different types. So you have an ID, name, status, which is enough, can be either open, closed, pooling, capacity, and these are trails that this lift serves. And as you can see here, we have exclamation points both on the inside and outside.
So we use a special type.
I use a special type
and find somewhere else.
It guarantees uniqueness. And likewise, this is a definition of a trail type. It has some additional field specific to trails. Then again, we have list of fields. Those are the definitions of two enumerations, lift status and trail status. Okay, so whenever you interact with between the client and the server, you always start your interaction with either a query or mutation or subscription. So that at the top of your interaction are you're going to decide what kind of interaction that is. So the most common one, of course, is a query. So in this case, we are using the existing types and defining a bunch of methods which allow you to query the system. So the first two, they return you all lifts and all trails. And the methods, they take parameters. You can get only the lifts which are given status, which are open or which are closed. This one returns a single lift based on its ID, single trail based on its ID, and two methods which give you counts of lifts and trails, again based on their status. And those are simple mutations and subscriptions. So mutation allows you to modify the state of your system. So in this case, we are changing the lift status. We are passing the ID of a lift and the new status, and likewise with the trail. And two subscriptions, they allow you to listen to such changes. So if you subscribe to lift or trail status changes, if one client calls this method, the client that's a subscriber will get the notification. So that's the idea.
There were comments in that schema. Are those comments if anybody wants to see?
Good question. Let's see. So there are two types of. So this is an interface that you get for free with GraphQL. There are two common interfaces. This is GraphQL Playground, and which is the new interface, and this is the this is the user interface called GraphQL. So GraphQL was designed, I believe, by Facebook as part of the GraphQL, and I don't remember who is the author of GraphQL Playground. But the idea is the same. GraphQL Playground has slightly different look and feel, and it has some features that GraphQL doesn't have, but they are some esoteric features that allow you to specify HTTP headers, for example. But other than that, they're pretty similar. So this is in both cases, this is the way to get the documentation. And so lift is a challenge, bundle, trim, funicular tool, right? Let's go back to the code. So this is GitHub. So those actual So I believe that yes, it does take the information from the comments and makes them available in the API. So this is the way for you to, before you start writing queries, to understand the API structure. So you can see the queries, mutations, and subscriptions. Yes?
And you defined the query structure inside those files. But how does that relate to like what's in a database behind it?
Excellent question. So let's go back to this idea of specification versus implementation. So GraphQL gives you a very flexible way to define your API. It constrains you in no way how you obtain the data. We'll get to resolvers in a few minutes, but so your implementation consists of two parts. First, you define your schema, which consists of the data types and queries, mutations, and subscriptions. And then you implement these queries, mutations, and subscriptions using resolvers. So resolvers are also part of the schema, but this is where the rubber meets the road. This is where you actually implement in the language of your choice how exactly these queries are implemented. And there you can do absolutely anything. Yes?
Are there particular databases that may work better with GraphQL?
Another great question. So there is a grand stack. And I mean, you can, let's say you're implementing your GraphQL server using JavaScript. You can talk to your MongoDB or your MySQL database today from JavaScript, right? So you can use same techniques you're using today to implement your REST API to talk to any backend. But so what Grant gives you? So Grant is GraphQL, React, Apollo Server, and Neo4j database. So Apollo Server is the company which implements, makes one of the most popular GraphQL tools, and specifically the server. So there is a GraphQL server, I believe, behind this, right? So right now I'm connected to the GraphQL server, which is what serves both the schema and the, I'm going to run the queries in a minute, and that too. So Neo4j has special tools which allow you to transform an existing graph database schema into a GraphQL schema. And then there are automated tools which translate your queries or mutations in GraphQL into the Cypher statements. Cypher is the query language used by Neo4j. So this is one combination which is known to work well. I assume that other database providers, there are probably tools, may not be by the database providers themselves, but tools by third parties that make it easy to connect GraphQL to other databases. Did I answer your question?
Yeah.
Okay. So again, GraphQL has nothing to do with databases, although it has query language in its name. I guess it was used mainly for sort of familiarity and cuteness, but all it is, it's an ability to It's a standard way to define an API. And how you implement it, it's tell that to you. So let's run a few queries to see how it works. So by default, it's a query. If I don't put any word, it knows it's a query, but it's probably cleaner to start. So you can start with the open brace, in which case it's going to be a query, or you can start with a query, and then you can open brace, and it tells me that I need a close brace, which is for me. Now if I do control space, it shows me what's available. So not only do I get the schema definition in the documentation portion of the interface, but I get it here as well. And so all lifts. And it underlines it. Why does it underline it? Because although I believe the parameter is optional, but I must tell it what information it wants to return. I don't think that there is a case here where you can say return everything. You can define the sets of variables and use them in many queries, but you must specify explicitly whether query what you want to return. So I open a brace and I see what's available. So I can get an ID, I can get a name, I can get a status, and let's close the schema definition. Let's run the query. So it works. There is an Apollo server behind the scenes which executes the query and returns the result. So in this particular case, the implementation is purely in memory. It's a very simple implementation. They define in memory JSON arrays of lifts and trails, and in response to a query, they return you this information. So notice that, so this is the HTTP response. It starts with either data or error, depending upon how lucky you are, and it gives you the name of the query and then the result. And notice that I ask the data ID name and status, and it returns ID name and status. So this is how you walk your domain model. So it's quite possible that you have this college registration application, right? So you can probably walk your entire graph, starting with a single student. You can say, given for this student, give me all his classes, and for every class, give me the professor who teaches that class, and for every professor, give me information on other classes that professor teaches, and for every class, give me information on all the students that teaches, or that are part of that class. So you can easily pull the entire database with a single query, and GraphQL allows you to do that. If you want to, again, if you want to deeply nest your, if you want to get back the entire database, you can do that. So you can carve your domain model in any way you want. That's sort of the most powerful thing about GraphQL. That you have a graph, and you can walk into your heart's content. Let's see how it works here. So let's add something. Let's add the trails, right? So this is the list of trails. And again, why is it right here? You have to tell it what I want. It won't accept everything as an answer. And now this is information about trails. So name and status and difficulty. And now imagine again, this is a very shallow domain model. It just has one level of nesting, but I could go on and on. So if I run this query, and now I get the result again tailored to my exact specification.
There's some sort of like JSON identity or where it doesn't reproduce the same. Like if it's say trail bluebird appeared on other lists, would it return it? Or is it?
You mean like a reference?
Yes.
I don't think so. This is a data object. It's like DTO, right? So it has a column.
Is it supporting paging?
Yes. So it does. So this is what it looks like, and if you go here to Star Wars API, you can do the same thing. So you start with query. So this is GraphQL. This is different interface, but same idea. All films. Here the API is slightly more clunky. For some reason, after all films, you have to say films, then you give it a title and director, and so we can see that New Hope was directed by George Lucas, and these are the vehicles it used. So again, similar idea, totally different API, but different environment, same lessons. And you have a history, so here you can see all the prior queries. Here. So I like this contrast between RESTful API and GraphQL API. In RESTful API, you have a large variety of endpoints. Each of them is finally sort of tuned to a specific client need. In GraphQL, essentially, you have a single endpoint, which corresponds to the entire domain model. It's not exactly true because you have those queries, but by and large, there's one endpoint. And you have utmost flexibility in the way you can traverse the domain model. So there are some constructs that you can use in creating the data. So you've seen something like that. So you're looking for a hero and the name of a hero. So this is a nested query, we've seen that too, right? You see hero and hero's friends, their names. You can name query and you can define arguments. So in this case, you're passing film's ID in your query. Now you define not just name query, but you define name parameterized query. And here at the bottom, and there is a special place in the interface where you can define your variables. So you would define variable here in this UI. And that's good. Go ahead.
So the user can only query on fields that you've allowed them to query on. Just because a field exists in the schema doesn't mean that they can query on that field.
Well, yes and no. So you can. So if you go back to the list of query definitions, let's go back to the plate and look at this. So you'll recognize this, right? All leaves, all trails, leaf trail. So it gives you a number of methods. But once you executed a specific method, right, you can traverse the relationship of whatever it gives you in any form of fashion.
I guess what I was getting at, so like it lived there, it has a capacity. So because capacity is a field, does that mean I can do a query where I specify the capacity and I only get back the libs that match that capacity?
Oh, I see. No, you cannot do that. The parameters have to be explicitly specified in your schema. So yes, if you wish to define a query which gives you a list of like capacity of X and more, you can do that. But no, you can request it at will, but you're going to filter based on it arbitrarily. You have to have. Why? Because somebody has to implement the result, right? It doesn't happen by magic. So if you define a query which takes a capacity as a parameter and returns only the lifts of certain capacity, right? The resolver would have to explicitly implement the code by going to the database and or iterating stuff in memory. Make sense? We can ls field. So here the original field name was title. We called it field title, and that's what gets returned. Query fragments. So if we're using the same collection of return fields over and over again, it gives you the ability to define a fragment and then use fragment with ellipses multiple times without repeating yourself. So this is a way to avoid repetition. Again, why would you do that? Because it makes it easier to reason about your code.
If you have a piece of code where you know that there's certain fields that you're just going to get back, like that, you give them an option. Another field like window, you select that, and you can execute this fragment back to the rest of the information.
Not exactly. If I understand you correctly, you're saying that in the domain model define the info field which contains this. No.
During execution, you go and you do your queries for data.
Okay.
And you're going to get the title, director, producers, like that.
Yeah.
Goes down. But this would allow you to, if the user said, goes to your user interface and says, I want the info about this, then this would allow you to get the info.
Well, this is the client side. So let me put it in the context. What I'm showing you here, we are not going to be doing that like in production, right? This is a playground. This is simply for you to explore the GraphQL API provided by a certain provider, right, and understand how it works. But you would do something very similar in your client. Only in your client, let's say you have a JavaScript React application doing that. You can define fragments and you can do it in your code, right? But this is strictly the client side. So it'll parse the query, will figure out what this means. I don't think the server will see that. The server will see the exact fields. So this is sort of like a syntactic should. You can use directives. So here you parameterize the query on a parameter, and you can decide at runtime whether to return certain values or not. So we've been talking about the queries, their annotations, and the goal is to update the data. So that's an example of a mutation from Star Wars API. We're creating a review for the episode. And so here at the top, you see the definition of the mutation. As you can see, it's parameterized. So it takes two parameters, EP and review. Here we have the JSON structure defined in these values, right? So you need to provide both. You need to define the query which provides them, and then for executing the query, you need to provide the value, and this is what you get back. And in the query itself, you call GraphReview method, and GraphReview returns some value, but you can choose which fields from that type you want to return. So it's a combination. You're modifying stuff, but also you're specifying what you want to get back. So here you got back stars and commentary. There were 5 other fields in the review object. We didn't want. Okay, now resolvers. So resolvers is, again, this is where the action happens. This is where you actually implement the logic. So this repetition, I'm showing you the list of queries. So this is similar to your interface, right, in Java. And the resolvers, this is your implementation. The difference is that the interface, the query definition and mutation definition, they reside in the realm of GraphQL, the schema language. The resolvers, they're down to earth. They reside actually in the implementation language because they actually have to do some work, right? So this is the JavaScript implementation of the resolvers. So resolvers, I'll get back to the code in a second. Resolver gets 4 parameters. The important ones are the second and third. So resolvers are implemented hierarchically for every nested field it calls on the resolvers. Most of the resolvers are trivial. Let's say if you want a field of an object, it simply returns the result of that field, right? So the first parameter is the result of a parent's resolver. Like if you are a nested resolver, but again, the important ones are the next two, the arguments. If your mutation has arguments, they're passed in the second parameter. And context, it's a special object. It's server dependent. Like in Apollo server, you can specify, you can initialize the context. You could put in constant information about users or database connections. So again, this is the implementation dependent. But all the resolvers get the context, and they can probably exchange information through the context as well. And the last parameter is rarely used, it's more for advanced use. You get the abstract syntax tree representation of query mutation. So let's look at the couple of those resolvers. All lifts. So root we're not using it here. Status on lifts, those are we're using the structure notation here. And so status was passed in, and lifts, the way this is implemented, we started Apollo server, and we simply passed 2 arrays of JavaScript objects. One array of lifts, of predefined lifts, and one array of trails. So all it does, it takes the context, which contains, among other things, again, so this is implementation dependent. This is not, the third parameter, this is not, has nothing to do with GraphQL per se. This is the specific implementation. It simply extracts the list of lifts from the specific implementation. The second parameter, that was that parameter passed from the client, which tells you what the status is. I think if the status is null, it will return everything, but if it's not, it will filter. Yeah, so if there's no status to return all lifts, otherwise filter them by the status. All trails, exactly the same. And then lift, this returns a single lift by ID. So ID parameter, and again, it uses instruction to extract lifts from the context. Any questions? Continuation of the implementation of resolvers. So lift count. I don't know why they're using that. I'm sure there is a better way, like using reduce to get the count. But the idea is that you provide the status, and they simply count how many lifts you have in that status, and same thing for the trails. You've seen that. So this is definition of the lift type, and this is the trail access implementation resolver for the lift type. So it returns you, doesn't even take arguments, looks like. So mutation is the ability to modify data, and again, remember that in your resolvers you can do anything you want. You're not constrained by anything. You have your schema, and resolver simply means that update my my database or data information memory. So this is the definition of mutation, and this is the resolver implemented that mutation. So we're first finding the lift to update in this line. And after that, we are, setting the status, and then using the PubSub to publish it. This is for the subscriptions. And in this case, PubSub, this is again server dependent. This is provided by the Apollo server. an object which allows you to manage your subscriptions. And this is the way to implement the subscriptions themselves, again using the PubSub object. And this is how you subscribe to get notifications of the LinkedIn Trail status change. So I mentioned Grand Step. Yes.
Just a quick question on the PubSub. So is it like the client? Is it like a React front end client that's subscribed to a particular query, right? And then you're getting back that information.
So yes, you have to. So you send queries, mutations, or subscriptions from the client, right?
Yeah.
And in the case of queries and mutations, you get back some results. In case of subscription, you become an observer, and from that point on, you receive notification for the given subscription the client receives.
Okay. Thanks.
So this is the Grand Stack. GraphQL, React, Apollo client, and Neo4j database. Okay, and let me quickly reiterate what the strengths of GraphQL as a technology, what the strengths are. So it strongly encourages you to the domain modeling, to start with defining the interface. It provides the language neutral means to define the interface, right? You get consistent of queries, mutations, and subscriptions. Strongly typed schema. This would be an improvement, right? If you're using JavaScript, you don't really get strong typing, and then all of a sudden, on top of your JavaScript server, you get a strongly typed schema-defined GraphQL. I think it's certainly evaluated. And you get auto-generated documentation. We talked about overfetch and underfetch, so this allows you again to exactly define what information you want to get back. So the query may return you the entire database, and you tell exactly which objects and which fields you're interested in. Rapid prototype. So it comes with a variety of tools which make it easy to quickly create APIs and then build the clients based on these APIs. Simultaneous development, and yeah, once you define the interface, once you define the contract between the server and the client, your client team can develop the UI, and your server team can implement the resolvers, realizing this interface. Support for languages. So JavaScript, that was the original reference implementation done by Facebook, and all the additional languages which support GraphQL. Schema stitching is the idea of allowing to take multiple GraphQL schemas and put a facade of a single schema on top of it. And then your clients would have only to deal with one API, even though there are multiple systems behind it. Large number of open source tools for all sort of stages of the life cycle. And also different clients. So the client is a tool which allows you to run the queries, mutations, subscriptions in your JavaScript code and browser. And there are tools for other things like Prisma makes tools for various databases. Mocker, if you have an API, it will probably just generate data to mock the API. You've seen GraphQL Playground, and I haven't tried the GraphQL. This is all. Any questions? Yes.
So if you take like a typical Java web stack, like you have a front end JavaScript application, back end REST API, maybe Jersey or Rails app or whatever, right? And then that server component is either running some embedded server container or it's deployed into a server container. Like, what's like the analogous parts. Kind of missing like where the resolver, like what you're actually building and deploying in terms of like a resolver part of it.
So I looked mostly at Node.js code, but I assume they will do something similar to Jersey or your Spring APIs or modules which allow you to let's just look at it.
So it's still like you would probably still run.
I'm sure, again, you're in Java land, so you'll have to produce the WAR file, but the WAR file will consist of, like today, what do you have? In Jersey, you define your controller.
Right.
A controller has annotation-based endpoints, right? So it will be probably annotation-based resolvers, right, which you would have. So when you do the JavaScript, what you do, you use a string, like a here dog in Groovy, to define your schema. So you feed the schema to special methods which generate, when you instantiate the server, you give it your queries, mutations, subscriptions, and resolvers for those, right? And the server starts and it knows how to implement, how to publish a query, how to process a query, which resolvers to call. So there should be something like that in Java land as well. An ability for you to provide a schema, and based on the schema, build your controllers, which implement the resolvers. So,
And so if I wanted to do like HTTPS with a certificate, and I was interested in the name on the certificate, can I still pass that on to my resolvers, or where do they get that from? Would that be in that context you described, or?
so essentially, you're trying to extract something from your from one of the HTTPS headers, or
No, like in the certificate.
like X509 certificate information.
Yeah.
Well, so typical, like even in Java applications, you terminate your SSL like in Apache and Nginx, and then insert an HTTP header, and then information will be in the header. So I don't remember. You can extract that information in the application itself. You don't have to do that. I haven't looked at security, but again, I assume that the same rules that govern the REST applications. So typically, you try to do the separation concerns, right? Most of the applications should deal with security concerns. So yeah, if you want to pass information to headers, I'm sure that there should be a standard way how you can extract header information. So, questions? Anything else? Okay. Thank you for patience.